Okay, sometimes we like to look at two sets of data side by side. And this could be things like if we're talking about a teacher, let's look at their first period grades, and then let's look at their second period grades. And we would have to try to compare these two sets of grades. Now, when you're comparing two sets, um, you're going to have to choose which is best, uh, mean deviation or median five number summary. And the way it works is uh, for a symmetric and symmetric. So if both distributions are symmetric, you're going to use mean and standard deviation. Now, if one of the graphs is skewed, or both of them, we're actually going to use the five number summary. And we're going to use that for both of these scenarios here. So I'm just going to slide this underneath both of them. It works for both the where they're both skewed or where one of them is skewed. Okay. Um, Now, when I'm taking a look at data, you have to graph them at the same time. Now, my spreadsheet is not set up to actually do that, where you can look at both of them at the same time in the program itself. So what you're going to have to do is you're going to have to look at one, sketch out what you need, and I'll show you how to sketch on this one without having to just copy and paste. That really hasn't been particularly fair of me. Um, but I'll show you what you're supposed to, kind of the key points to pull out there. Um, and then what we're going to do is do it for the other set of data. So, okay. Sorry, I had to double check something real quick to make sure I had the right stuff here. Let's go ahead and take a look at example 3. So using a graphing calculator or Google Sheets, let's create a histogram for each data set, then describe the shape of each distribution. So I'm going to just leave a little bit of space here, go over to my uh, spreadsheet, go to the histogram page. I'm going to get rid of this old data. Now, um, data for 11.2, example 3. So we got the chapter 3 test scores. Let's bring all this down. Copy that and put it in, not the box and whisker, but the histogram. Ooh, so you can see here what it's got set up is not a good breakdown for the histogram. It looks like either you got a D or you got 100%. So that is not a good breakdown there. We're going to have to click Edit Chart and go to Customize. Um, Histogram, and right now it's set on 50. Let's bring it down to tens. Isn't that what we normally look at for grades, going by the tens? I mean, if you wanted to be, whether you're looking at positive and pluses or minus on the grades, you could put it down in fives. But I'm thinking tens is going to be, yeah, let's let's do fives. Okay. So you can see there's definitely a higher spot here in the middle. I close that down, and you can see the mean and the median are pretty close to each other, right? 81.3 and 82. So there might be a little bit skewing here, but that's pretty close in terms of uh, mean and median. So what I'm going to do is take a look here. Let's think about where it goes. It goes from 61 to 66. I almost kind of want I don't want it to start at 61. Let's see, can I get it to start? Let's go to the horizontal axis. Minimum value. How about you just start me at 60? Is that doable? Uh, Maximum value. How about 100? That didn't really change anything about the graph. All right. So that experiment died. So I'm going to sketch this out onto my paper. So let's see what that looks like when I sketch it out. So I'm just going to draw a histogram, right? And my top was 10, but I had one, 9 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And this went to 61, 66, 71, on the pattern all up to 99. You could, if it wasn't on a video, I'd put all those numbers down, right? Now, it looks like I need to go from 10. So how about let's go by twos? 2, 4, 6, 8, 10. And what I like to do, particularly with another color, I just like to write the top here. In the first box, it stopped at the twos, and then it looks like it stopped at 3, back down to 2. For the next one up, it was up at 5. You can see if I had been a little bit more careful with this, I would, oh man, that one goes all the way up to 10. I would actually have lined it up with all of the lines on the graph. Got to bring that back down to 5s there, and 3s, 2s, and 1s. So there is my histogram, and the mean and the median were about 82. So I'm going to put a little line right here. That's 71, 76, 81. So 80, 81.3 for the mean. Okay. All right, so that looks pretty symmetrical. And to save time, so you don't have to see me draw out another one of those in real time, I'm going to go ahead and I'm just going to copy and paste the next one in. And let's see here. I'm going to just check my histogram again. Bucket size is 5 still. Okay. Copy chart. You can see this one is actually a little bit bigger. But this one doesn't seem to be as spread. You know, I'm kind of actually... Ooh. Man, that's even worse when I do it by twos. Well, there definitely seems to be a little bit of a tail on this one. This guy out here seems to be an outlier. And when I look at the... No, it's still looking kind of symmetrical, I guess, because the mean and the median are both 79 according to my calculations. So, there we go. So here it looks like we have a symmetrical and symmetrical distributions. Now, since it's symmetrical and symmetrical, the best way to describe them are with mean and standard deviation. So we're going to do means and standard deviation. So now I'm going to put that same data that I had. So this is the data for the second graph there. I'm going to put that into data 2. And go back in here. Data for 11.2. Chapter 3 tests. Let's take those things. Copy those off. I don't want to put them in data 2 because I've already got that there. Let's go ahead and put it in data 1. Alright, and let's compare the things. So mean, and we'll use the population standard deviation. Mean is 81 and standard deviation is 10, or like 9.5. So chapter 3, mean of 81.3, standard deviation of 9.5. Chapter 4, mean of standard deviation of, that was on data 2 tab. Yep. Mean of 79, standard deviation of 5.9. So 79, 5.9. How would you compare these two grades here? Well, um, on average, let me give myself a little bit more space. On average, the grades were better in chapter 3. 81.3 is greater than 79. However, and this is where the standard deviation comes in. However, chapter 3's spread is larger, meaning more people were at the extremes. Some people really got it, some people didn't get it. We got some D's, we got some A pluses, right? With a tighter deviation here with the lower grade, yeah, maybe the overall grade was lower, but everyone had pretty much a better, a more consistent um, type of understanding, right? It's a tighter curve in the middle instead of a very broad curve, right? That's the difference between these two situations. So this part here can be tricky, trying to describe what it means.